Brian and Steve. Appreciate that. Good morning, everybody.
Morning.
Time hasn't changed yet. I'm not speaking at 8:30 tomorrow. That's weird. I'll be tired too. Thank you. As they said, I'm from Kentucky State University, and I'll tell you a little bit about some of the flounder we've been working on and some of my perspectives related to that. So, the general introduction here: U.S. consumes seafood. We import most of our seafood. We don't really, have a lot of control over where that comes from and how it's raised. Overall, Americans don't eat as much seafood as they should. A lot of our counterparts in Asia and other places eat a lot more seafood than we do. We'd be better off if we ate more, though, and we'd be probably better off if we produced more here at home, from an economic standpoint at least, probably from a food safety standpoint and other things as well. And so we're looking at intensive marine recirculating aquaculture systems in places like Kentucky, where we're in a completely landlocked state, and we're looking at systems that have very low water exchange rates, less than 5%, throughout the entire life cycle of the animal, essentially. And we've been able to do that with shrimp and things like biofloc systems. And that's kind of my background, was the biofloc systems. That's where I started almost 20 years ago, and I've progressively towards some of the more intensive clear water type recirculating systems that many of you work with now. And I've found it to be a really good opportunity, although we need to intensify and produce a lot of animals in these systems to justify the cost of the equipment it takes. So what we can do is produce fresh, never frozen seafood. Practically, if we could do it right, we could produce this anywhere in the world, practically. This is a shrimp farm in Ann Arbor, pretty high tech. This guy's he's going to be doing shrimp, but I think he could do flounder too. Actually, I know he could if he wanted to. So. Shrimp is doing okay in the U.S. It's an interesting little industry. There'll be some more about this. Not Saturday morning. I believe this is Sunday morning. Anyway, it's called Protein 5.0 Shrimping Session. I don't know a lot about why it's called that, but they're going to give some presentations from some industry folks that have more relevant commercial experience in U.S. shrimp farming. So we see quite a few of these small-scale shrimp farmers around, at least. These are most of what I work with, and they, pretty typical setup here. Above-ground swimming pool and some homemade filters, mostly things you can buy from your local hardware store and kind of keep it simple. But there are some more large-scale farms coming online. I think the guy from Transparency is going to have a talk at that session, so that'll be interesting. As an example of a larger type of operation. So, shrimp is a warm water animal, tropical animal. Relatively low biomass production in these systems. Historically, I always thought we were doing good. We could get like 5 kilos per cubic meter. We've upped that a little bit. Clear water systems, now we're looking more towards 10, 15. I think Bert's going to have a presentation later where he's probably crushed those numbers now. But still, you look at things like salmon, it doesn't really compare in terms of biomass. One idea is to look at some alternate species that could be used maybe in cooler conditions, like we have a fairly temperate climate in Kentucky, for instance. And I took a trip to Korea in 2019 and saw what they were doing with the olive flounder. They produce 55,000 tons per year, primarily in a little island off the southern coast of South Korea, Jeju Island, which is a really pretty place if you get a chance to go there. But it's rimmed by flounder farms, and they're having some problems with disease. They're flow-through systems. They have saltwater wells, they pump water up and then discharge into the ocean primarily. And they have some real nice beaches there, and the flounder farms are having problems with the beaches, making problems with the beaches, that is. But the fish itself is really interesting and really exciting. The farmers that use the shrimp farmers rather that use flat bottom tanks, I think, are poised to switch over to this fish if they want to, and produce more biomass in the same type of system. And the fish itself is often called harame. I was in Korea a few months ago and had some that had been swimming like 5 minutes prior. It's super fresh, and it's a delicious fish, very popular among consumers. In the United States, flounder is pretty well known. It's already, it's not one of these fish that's exploratory in terms of marketing. It's well known, especially near the coast. We don't have to call it olive flounder; we can just call it flounder. And some of the flounder fisheries in the United States are being diminished, or they're down quite a bit. I'm from North Carolina, and I know the North Carolina flounder fishery is not anything like it was when I was a kid. Sometimes it's only open for a day or two in the entire season because the catch limits are so small. So yeah, they're having some trouble. We're working in Korea. They're moving towards more RAS as well. I was just there. There's a few farms that are moving towards RAS technology, even in Korea, for the reasons I mentioned. We're working with the University of Miami. My co-author, Dr. Stieglitz, is here, and they've been working with this fish for quite a while, reliably spawning and raising flounder. They've got some brood stock on hand, and they've worked out a lot of the bottlenecks with regard to production. So I don't want to speak for Dr. Stieglitz, but it seems to be pretty impressive the way these fish can just spawn practically without much control at all. Not much lighting or temperature control that I saw. They're like rabbits. So we're looking at low water use, intensive filtration to keep that water use down. I've seen them growing a biofloc in Korea, so that might be a possibility. Not something I've looked at yet. Doing more of the clear water systems. When you're thinking about filtration, feces is something to consider. This fish has a very dilute feces. It's just like a little cloud of black that comes out. So something to consider. You need some good solids filtration for that. High protein requirement. That's probably one of the downsides of the fish. Carnivorous marine fish, needs 50% plus protein. We've got 55% grower diet that we're using. Temperature around 23 degrees Celsius is ideal, so we oversize our nitrifying filters compared to what we would with fish. And again, we're trying to achieve super high biomass with these fish, so we're sizing our filters pretty large. I had a talk yesterday about denitrification. This is our denitrification MBBR over here. About 15% the size of our aerobic filter. Pretty standard setup here, I think, for most of you. This is all kind of new to me, but these are the filters we're using to maintain clear water and use very low rates of water exchange. These fish will stack on top of each other 3 or 4 layers deep, really interesting, and they'll just lay there, and they just rest on the bottom most of the day. They're one of the most docile fish I've ever worked with. Even in the tanks, I'll net them up, and they'll just kind of lay there in the net. They're really chill fish until it's time to feed. Then they get really active, really aggressive, and that's a real opportunity, I think. Well, first of all, at low density, they don't get very aggressive. But when they're at higher density, they do tend to be more aggressive, as with some other carnivorous fish. But outside of the time that they're feeding, they have a very low oxygen consumption. So for RAS, I think it's a real opportunity. Using pure oxygen, you can use it just during the time of feeding. So we would use it for about 2 hours a day, and that's it. The rest of the time, the metabolism slows, and you're able to get away without any pure oxygen addition. Not to mention that the fish is very efficient because it doesn't spend a lot of time swimming. It just lays there growing, and so the FCR is 1, 1.1, 1.2 to 1. Very low FCR. They'll lay on top of your diffusers. That's a little side note for RAS. But since they are a flatfish and lay on the bottom, a lot of people are looking at more shallow tanks. I was never really